everyone, this is Miss Moriarty and I'm here to discuss with us topic 6.5, which is all about fossil fuels. So we will talk about the different fossil fuels from class, their advantages, disadvantages, and so on. So first in our discussion of fossil fuels, we're going to talk about how does fossil fuel combustion work. If you can recall back from Unit 1 when we discussed the carbon cycle, we talked about how combustion is a process that's going to burn organic compounds such as fossil fuels that have been trapped underground for millions of years and return that carbon back to the atmosphere. So when we combust fossil fuels, there's a reaction that takes place between oxygen gas and the hydrocarbons that help to make up fossil fuels. When this takes place, the chemical bonds that hold the carbons and hydrogens together break and release tremendous amounts of heat energy. That then produces greenhouse gases such as CO2 as well as water vapor. Now here we can see, right, remember combustion we said was a step in our carbon cycle, and that's because of the hydrocarbons that help to make up our fossil fuels. Now besides combusting things like coal and gasoline, the same can be said of methane or natural gas. Propane, butane, which are all other forms of natural gas as well, are going to burn pretty much in the same exact way. We can also think of wood and biomass burning in a similar manner too, especially since all of them are organic compounds. They've all come from a living thing at some point. So when we combust them, we're all going to see the same result, right? Carbon dioxide will be given off and energy will be released. How do we then wind up generating electricity from the combustion of all of our different fossil fuel types? Well, all thermal power plants are going to convert the potential energy stored within the bonds of fossil fuels and turn that eventually into electricity. So a big part of that is actually using turbines, which is a device that's going to look similar to, let's say, the blades of a fan. The turbine can be used to turn things like water, steam, or even wind, and this eventually will produce power. That power or electricity will then be used in a network of different transmission lines to eventually deliver that power all over a city or maybe a suburb via an electrical grid. When we look at the number one source of electricity globally, we tend to see coal being the first option, followed by natural gas. Coal, oil, natural gas, biomass, and even trash can all be burned to drive energy in this same process. And even nuclear energy, which we mentioned is also a non-renewable resource, creates or transfers energy in the same way as our fossil fuels do too. Here we're going to talk about how do we generate electricity specifically using coal. In our first step, we're going to combust or burn our coal source, and that energy, or at least heat energy, is going to turn water into steam. That steam is going to produce kinetic energy, which is then going to turn the blades of a turbine, and you can kind of see that in this diagram here. As the energy in the steam turns that turbine winds up turning a generator, and eventually that generator is what's going to generate electricity and eventually be delivered outwards via an electrical grid. Now, a more sustainable option that coal-powered plants can use, and even natural gas power plants as well, can be a process known as cogeneration. When we burn things like coal, or even when we burn things like natural gas, they're really only so much efficient, right? They're not going to always be 100% efficient, especially when we burn something, right? It's going to release a lot of leftover heat energy that can't necessarily be harnessed into electricity. And we know that back from when we talked about the law of thermodynamics, right? As you increase in entropy, the randomness increases, it loses its ability to do work. So much of the energy winds up getting lost, right? Is not converted into electricity. So, through a process known as cogeneration, any of that leftover or lost heat can actually be used to heat the building itself, or maybe even heat water once again for that building. And so, having a more combined heat and power system can be closer to now 90% efficiency rather than 30% or only 60% efficient. What are some of the then environmental consequences of using coal? Well, two major pieces here. One would be the habitat destruction that is used in order to mine for coal. And two would be the fact that it produces several different air pollutants, as well as greenhouse gases that is going to influence global warming and climate change. Now, more specifically, we know that it's going to produce carbon dioxide, but it will also produce air pollutants such as particulate matter in the form of soot and ash. Particulate matter are very tiny particles that have the ability to irritate our respiratory tracts whenever it is breathed in via either human or animal. It can produce toxic ash, especially when mined for, and that toxic ash can contain high levels of lead, mercury, and arsenic. Now, it can be taken to landfills or stored in ash ponds. And if you can recall, whenever we happen to store something in a pond, maybe even like the manure lagoon from a CAFO, it has the ability to potentially contaminate local ground or surface waters, and maybe even the soil itself. And besides releasing particulate matter, greenhouse gases, it has the chance to produce two other types of air pollutants that we will have to know in much more familiarity in Unit 7. But the two are sulfur oxides and nitrogen oxides. Together, both of these serve as, once again, respiratory irritants, but they also contribute to smog and acid precipitation or acid rain. Moving on to how we extract petroleum or oil, that's usually through a system of wells that we drill into the rock, and we tend to pump liquid out under lots of pressure in order to obtain petroleum. It can also be recovered, however, from a substance known as tar sands, which is a combination of clay, sand, water, and bitumen. Bitumen is a semi-solid form of petroleum. However, when tar sands is obtained, it can be extremely expensive and water intensive in order to purify and extract the oil. Lots of water is going to be needed for heat, and that's going to obviously require a lot of energy. That is going to create steam that's then piped down into the tar sands to then melt the bitumen into a liquid form so that it can flow up the pipe. Lots more water is then used to then separate the oil from all of the other impurities found in the tar sands, such as sand and clay. And so, although we can obtain petroleum from tar sands, it serves as an alternative, but is certainly not a main source of how we obtain it. Now, some environmental consequences of using petroleum or tar sands. When we drill for oil and when we transport it to other countries, there is a possibility of oil spills, either maybe from a tanker ship or maybe a pipeline breaking. If it happens to spill in water, there are tremendous environmental impacts. The crude oil that spills into the ocean can wind up blocking sunlight. It could clog the gills of fish. It could suffocate ocean animals, sticking to bird feathers, preventing them from being able to fly, migrate, and so on. If it winds up spilling on land, or even if it spills in the ocean and winds up along the shore, it can be toxic to the roots of plants. It can be toxic to surface and groundwater, especially if they are contaminated. In order to obtain petroleum, similar to coal, this is going to require habitat destruction, right? We must clear the land to install drilling equipment, roads for that drilling equipment, transporting it, and so on. It has the risk of contaminating any nearby surface water, and it's going to deplete simply the amount of surface water nearby, especially if we need to use it at a refinery if we are collecting tar sands and trying to extract the petroleum from it. It can also, similar to our coal, contaminate water by the tailing ponds, so really anything that's left over from the extraction of bitumen. It can release toxic materials such as benzene, which is a carcinogen. It can release acids, hydrocarbons, and so on, or maybe even leftover bitumen that wasn't necessarily fully extracted. And together, all of these can be very toxic to plants as well as animals that live nearby. And then lastly, obviously the combustion of petroleum and using all of the machinery that's used to drill for petroleum in all ways, shapes, and forms produces greenhouse gases. Then lastly, moving on to how natural gas is obtained. It can be obtained similarly as petroleum in that we do need to drill down vertically into earth. Usually natural gas, however, is done through a process known as hydraulic fracturing, in where they're going to take fracking fluid, which is usually a mixture of different substances like waters, salts, detergents, and so on. That fracking fluid is usually pumped at a very high pressure, high speed to create small little fractures in the rock, which is then going to release the natural gas that may be trapped within that rock. And eventually, what they do through a system of pipes, they can obtain whatever natural gas winds up being released through the hydraulic fracturing process. So then lastly, what might be some environmental consequences of fracking itself? Here, the possibility of the wells leaking and contaminating groundwater with the fracking fluid is a very high possibility. Ponds, where they wind up storing some of the fracking fluid, can always overflow, leach into the soil, groundwater, and so on. Any of those items can be toxic to us, to plants, nearby animals. Using a hydraulic fracturing equipment can also contribute to habitat loss, habitat fragmentation. And then through hydraulic fracturing, some of the methane that maybe gets released in this process may not 100% be obtained. So it has the ability to release methane, which is a greenhouse gas. And then using the fracking fluid requires water in the first place, so it also depletes any ground or surface water that might be nearby. Okay. And then lastly, because we are drilling into the ground, creating these tiny fractures in the ground, it can increase seismic activity in the nearby area, and it can also be linked with any wastewater injection wells as well. Okay, lastly, this is our practice FRQ for 6.5. So if you want to take a moment and write this in your practice FRQ journal and on the Edpuzzle. Here it states, describe an environmental problem associated with the disposal of coal ash. Right? Here are some items that you could say that would be accepted answers in this case. Remember, with the disposal of coal ash, we can wind up leaching toxic metals such as lead, mercury, and arsenic from landfills. We could have an overflow of the coal ash into maybe nearby bodies of water. We can contaminate groundwater, soil. The coal ash could maybe wash into other bodies of water as a result of severe weather events. Dry ash could be carried into any other nearby bodies of water, increasing the turbidity, right, making it very cloudy, blocking sunlight, preventing any photosynthesis. All right, everyone, that was our video on 6.5. If you have any questions, please leave it at the end of the video.